Okay, here we go. Today we are still talking about solving equations, but in this case, we are now going to have variables on both sides of the equal sign. Everything that we've done up until now has only had a variable on one side of the equal sign, which makes it relatively straightforward to do. But now we're going to have variables on both sides of the equal sign. And the key is we just need to get the variables on one side and the numbers on the other side, and then we can solve the equation. Okay, so we're going to start by looking at one of those hangers or mobiles again. And the first one, it says, suppose a circle is worth 60. So I'm going to write 60 in the circle. And a triangle is 40. Set up an equation that could be used to solve for the missing value, then solve for the missing value. Okay, so I'm going to do the same thing that I did with the other lesson. Instead of circles, this time it's squares that we're looking at. And we can see that on the left-hand side, we have 1, 2, 3, 4. And I used x's again, right? So on the left-hand side, I'm going to have 4x plus 40. And then that's equal to what's on the right-hand side. And on the right-hand side, I have 2 x's. So I have 2x plus 60. Okay, so it's just all about identifying those variables and then adding or subtracting whatever we need to do to set up the equation on both sides. Okay, so now with this, we want to now be able to solve this. And like I said earlier, all we have to do is get the x's on one side and the numbers on the other side, and then we can solve it. And the key thing to look for is the smallest x. In this case, 2x is smaller than 4x. So I'm going to start with the 2x, and I'm going to subtract 2x from both sides. Okay, I could start with the 4x. That would not be a problem. But if I started with the 4x and I subtracted 4x from both sides, I'd end up with a negative 2x. And negative numbers are a little bit more challenging to work with. So if you always start with the smaller x value, then you will be able to not run into negative numbers. Okay, so when we subtract 2x from both sides, I end up with 2x plus 40 equals, the two x's cancel each other out on this side, 60. Okay, so in that first step, I was able to get the x's on the left-hand side. Now I want to get the numbers on the right-hand side. And it's just a two-step equation like we've done before. So I'm going to subtract 40 from both sides. So when I do, it cancels on the left-hand side. So we have 2x is equal to 20. And now I have the x's on the left-hand side, the numbers on the right-hand side. I'm just going to divide by 2. And I know that x is equal to 10. And it's pretty straightforward to come over and check our work. So we can just go ahead and plug 10s in here. And then 10s in here. And we have 4 10s plus a 40, that's 80. And then we have 2 10s and a 60, that's 80. So they both balance. So they're equal to each other. So we know we have the right answer. Whoops. All right. So it looks like we just have, oh no, we got a couple, here we go. So I have 3 examples here I'm going to show you. You get to do 3 on your own, and then we'll have 3 more, and then you get to do a bunch on your own. So in the first example, remember we want to look for that smallest x. In this case, it's a 2x again. So I'm going to subtract 2x from both sides. So 7 minus 2 is 5. So we have 5x. Bring down the plus 45. The 2x's on the right-hand side cancel. And then this is one where we can easily make a mistake. We'll bring down that 16, but we'll forget that minus sign. We don't want to forget that minus sign, so it's negative 16. And then we're going to get the numbers on the right-hand side, so we're going to subtract 45. Okay, so we have 5x, 45's cancel. And then these are both negative, so all I need to do is add them together and keep the negative sign. So this ends up being negative 61. Okay, and then I'm going to divide both sides by 5. So the 5's cancel, so we have x is equal to, well, 5 doesn't go into 61 and end up being a nice neat whole number. It's going to end up being a decimal, so it's negative 12.2. All right, if you need a calculator to do that, that's perfectly fine. I didn't need one, but that's okay. If you need a calculator, I want you to use a calculator. All right, the second one. So the second one introduces a negative coefficient in front of one of the variables. So in this case, we have a negative x. And remember, that's a negative 1x. And negative 1 is smaller than 5, so I'm going to start there. I'm going to start by adding 1x to both sides. So we have that one cancel out, so we have 14 is equal to 6x plus 13. Okay, and then I'm going to get the numbers on the left-hand side in this case, so I'm going to subtract 13. So we have 1 is equal to 6x because these cancel each other out. And then this is one where a lot of people will say that the answer is 6, but we got to be really careful because we are dividing by 6. And when we divide 1 by 6, the answer is just 1/6. Okay, so x is equal to 1/6. All right, let's try another one. Okay, so this is one where you might look at the variables and say that 10 is smaller than 12. And you'd be right, 10 is smaller than 12. But in this case, we have a negative 12. And a negative is always smaller than a positive. So we are going to start here and we're going to add 12x to both sides. Okay, so we add 12x to both sides. We end up with 22x plus 60 equals 30 because these cancel each other out. And then I am going to subtract 60 from both sides. And we have 22x. The 60s cancel is equal to negative 30. And so I'm going to divide by 22. So the 22s cancel each other out, so I have x equals negative 30 over 22. Now, this number doesn't end up being a nice, neat decimal when we divide it. So what we want to do is simply just reduce this fraction as low as we can. So I'm going to reduce it by dividing by 2. So I end up with negative 15 over 11, and that's all I can do. Okay, so that was a lot, pretty quick too. What I want you to do is pause the video and try these 3 problems on your own. And if you need to, go back and watch parts of the video again if you're struggling with some part of this. And when you finish these 3 problems, go ahead and restart the video and we'll go through some more examples. All right, here we go. 3 more examples before you get to do, what is it, 9 on your own. Wow. All right, so 3 more examples. So if we look at this first one, again, I'm going to identify the smallest variable. So the smallest variable is a positive 3x. So I'm going to subtract 3x from both sides. So 5x minus 3x is 2x. Bring down the minus 12. Don't forget that minus sign. Equals, they cancel, so we have 16. I'm going to add 12 to both sides. So 2x equals 28. And then I'll divide by 2. So x equals 14. Wow, a nice neat number instead of a fraction or a decimal. That's kind of unusual. All right, here we go, another one. Ooh, 4 is smaller than 9, but is negative 4 smaller than negative 9? Nope, it's negative 9 that's smaller. So we're going to start there. Now again, it doesn't matter. If you started with a negative 4x and added 4x to both sides, that's fine. You're just going to end up with a negative sign to deal with. And hey, I'm confident that you could do it. Okay, so I'm going to start by adding 9x to both sides. Okay, so that cancels. Negative 4x plus 9x, so that's going to be positive 5x. Bring down the plus 13 equals negative 22. And then to get the numbers on the right-hand side, I'm subtracting 13. So we have 5x equals negative 35. Anytime they're both negative, I just like to look at them and say, hey, I'm just going to add those two numbers together. I'm going to ignore the negative signs when I use a calculator. And then I'm just going to add them together and make it negative when I'm done. Okay, so then I'm going to divide by 5. So we have some canceling going on there. So x equals negative 7. All right, you'll notice I forgot to say, ooh, the 13's canceled up here. Sometimes I'm going to do that. And it's okay as long as you recognize that those are canceling. All right, one more. Which one's smaller, x or x? Remember what I said about negatives? Negatives are always smaller. So this one is going to be smaller than the positive x on the right-hand side. And they're both 1s. So I'm going to put 1s in there. So the one on the left is negative 1, obviously. So I'm going to add 1x to both sides. Okay, so the 1s cancel each other out. So we have 8 equals 1 plus 1 is 2. So we have 2x minus 13. And then I'm going to add 13 to both sides. So 8 plus 13 is 21. So I'm going to bring down the 2x, cancel those. And then I'm going to divide by 2. Oh, 21 divided by 2. It's not a nice, neat number, but it is a nice, neat decimal. It's 10.5. So the 2's cancel. So we have x is equal to 10.5. Okay. So there we go. You have 9 problems to do down here on the bottom of the page. When you are finished with this assignment, what I want you to do is submit all of your answers in the red boxes to the assignment on Schoology labeled 4.3C.